Hello everyone, my name is Jeremy Basabe. This is topic for lesson 1, Fundamentals of Diagnosis and Troubleshooting. The fundamentals of diagnosis and troubleshooting refer to the basic principles and techniques used to identify and resolve problem or issue in a system, device, or a process. It, it involves systematically analyzing symptoms, gathering relevant information, and applying logical steps to determine the root cause of the problem and implement effective solution. Second slide. The most important points for troubleshooting your automotive. First bullet, correctly identify the symptoms of the malfunction. When troubleshooting, it is important to correctly identify the symptoms that the customer points out. Second bullet, work efficiently to determine the estimated cost in order to find the true cause. To correctly and promptly perform troubleshooting, systematic work is required. Slide 3. Asking the question, why is of great importance? First bullet. When a technician makes estimation about the cost, he must check whether facts that support this estimation exist or not. Second bullet. To troubleshoot true cost, the technician must adopt a habit of following the cost and effort relationship of each item by observing the following cycle: estimate and verify, estimate and verify. Fourth slide, troubleshooting procedure. The troubleshooting procedure consists mainly of 5 stages. When a technician troubleshoots and does not follow the necessary procedure, that malfunction could become complicated, and finally the technician may perform irrelevant repair procedure due to the wrong estimation. To prevent this, he should understand the 5 stages accurately when troubleshooting. Ito na po ang 5 stages. Stage 1, verifying and reproducing the symptom. Verifying and reproducing the symptom is the first step in troubleshooting. The most important element in troubleshooting is correctly observe the factual malfunction symptoms that the customer points out and make an appropriate judgment without any preconceptions. Stage 2, determining whether or not it is a malfunction. When a customer makes a complaint, there are various cases. Not all not all of the symptoms are related to malfunction, but could be the characteristics inherent to that vehicle. If a if a if a technician repairs a vehicle that has no malfunction, he will not only be wasting time, but will lose the customer's trust. Hindi na po magtitiwala yung customer nun. Stage 3, estimating the cause of the malfunction. Estimating the cause of the malfunction should be done systematically based on the malfunction symptoms the technician has confirmed. To accurately estimate the cause of a malfunction. Stage 4, inspecting the suspected area and finding the cause. Troubleshooting is a step-by-step, repetitive process for approaching the true cause of a malfunction based on facts, data obtained through verification and inspection. Stage 5, recurrence prevention. Repairs are completed not just when the malfunction is eliminated, but when the fear of recurrence has not been removed. Let us proceed to the next topic, Lesson 2, Diagnostic Tools and Equipment Types for Post and Operation. Let's proceed to Lesson 2, Diagnostic Tools and Equipment Types for Post and Operation. Letter A, Compression Cylinder Leakage and Vacuum Tester. Image 1. Compression tester is used When there is a suspicion of low compression, performing a cranking compression test. Remove any spark plug, wires, or ignition coils connected directly to the spark plugs. Disable the ignition system by grounding the coil wires or disconnecting the coil primary circuits. Disable the injectors or remove the fuel pump fuse or relay. Remove all, remove all spark plugs. Connect the compression tester to the spark plug hole to be tested. Performing a cracking compression test. Hold the throttle down and crank the engine over so that the compression tester needle jumps at least 5 times. Record the first and last needle readings. Repeat this procedure on the outer cylinders. Perform a wet test on a cylinder with low compression. Determine any necessary action. Vacuum gauge. Measure amount of vacuum an engine can generate. Vacuum gauge determine engine's general condition. Testing engine vacuum using a pressure transducer. Image 1. Connect the pressure transducer to intake manifold and the lab scope. Connect the second channel of the lab scope to the ignition system so it can identify cylinder 1. Start the engine and let it idle. Adjust the lab scope so that the screen captures the vacuum pulses for all the cylinders. Observes the vacuum trace and compare it to known good readings. Snap accelerate the engine by opening and closing the throttle and compare the trace to known good readings. Hold the throttle steady at 1200 and 1500 RPM and compare the trace to known good readings. Then hold the throttle steady at 2500 RPM and compare the trace to known good readings. Cylinder leakage tester pumps are in air into cylinder and measure percentage of air leaking from cylinder. Cylinder leakage test overview. First bullet, cylinder leakage test is performed on cylinder with low compression to determine severity of compression leak and leaks location. Second bullet, compressed air is applied to cylinder to show amount of leakage. Ideal reading is 0% up to second up to 20% is acceptable. Third bullet, several critical steps to ensure tests are accurate. Engineer operating temperature. Fourth bullet, separating critical step to ensure tests are accurate. Engineer operating temperature. Run engine at 1500 RPM for 10 to 15 seconds. 5. Blows out chunks of carbon straddling spark plug. Cylinder leakage is measured when piston is atop dead center on compression stroke. Performing a cylinder leakage test. Step 1. Remove the spark plug of the low compression cylinder and any adjustment spark plugs. Install the cylinder leakage tester adapter hose into the spark plug hole. Step 2. Position the piston for the cylinder being tested atop dead center on the compression stroke. Step 3. Connect the compressed air hose to the tester and adjust the tester so it reads 0. Contact the cylinder leakage adapter hose to the tester. Make sure the engine does not turn over. If the engine turns over, you will need to reset the piston back to the compression stroke. Record the reading. Listen for leakage from the oil fill hole, the throttle body, and the exhaust pipe, and look for bubbles into the radiator. Performing a fluid leak inspection by looking under the bonnet. First image, check for any coolant leaks. Check the radiator hoses, heater hoses, water pump, heater control. Check for engine oil leaks or seepage at the valve covers, intake manifold, cam seal, and so on. Check for check for power steering leaks and at the power steering pump lines and steering box or rack and pinion. Check the master cylinder brake lines. Check the rear seal of the brake master cylinder, looking for signs of seepage between the master cylinder and the vacuum booster. Performing a fluid leak inspection by looking under the vehicle. First image, check for the coolant seepage or leakage on each side of the block around the soft plugs. Inspect for engine oil leaks around the front, main seal, oil pan, oil filter, oil pressure switch, and rear main seal. Performing a fluid leak inspection by looking under the bonnet. First image, inspect for transmission and Troxocell leaks. Inspect the front and near differentials if equipped. Letter B. Dwell and tech meters. The, tech, the tachometer's function is self-explanatory. It measures engine speed in revolution per minute. The dwell function measures the degrees of distributor rotation. The ignition points are close and is directly related to ignition point gap. In fact, the ignition point gap can be set by adjusting the dwell angle. Step 1. Attach the red or green leads on your meter to negative terminal on the ignition coil. Step 2. Attach the black lead on your meter to any good ground on the engine. That is an unpainted metal part. Step 3. Set the meter for the number of cylinder your engine has. There should be switch with engine settings on it. Letter C. Engine Analyzer. Engine analyzer determines engine's general condition. Second bullet, the analyzer processes all the information and presents results on the state of the vehicle engine's condition, identifying, for example, any uneven balance between cylinder, worn timing chains, and compression problems. Fuel system electronics control using all ECU, emission levels, battery charging system, and primary and secondary ignition system. Letter D. Diagnostic scanners. First bullet. Scans tools communicates to vehicle computers through data link connector or DLC. Retrieving and recording DFCs, OVD monitor status and freeze frame data. Step 1. Select the scan tool to provide the best coverage for the type and make of vehicle. Locate the DLC and connect the scan tool. Step 2. Power on the scan tool and turn the ignition on. Establish scan tool communication with vehicle. Step 3. Retrieve and record the DFCS. Step 4. Retrieve and record OVD monitor status. Step 5. Retrieve and record freeze frame data applicable to the DFCS and monitors. Last step, step 5. Power up power up power up the scan tool, turn the ignition off and disconnect the scan tool. Thank you.